Hi, in this lecture we are going to build on what we've learned in the previous lecture, and once we have the ESP32 connected to the local Wi-Fi network, we'll get it to go out into the web and fetch the contents of a text file which is stored on a web server. In my case, I've got the file that I'll be getting the data out of on an Amazon S3 bucket. But it doesn't need to be that. It can be a text file, as I said, stored on any accessible web server. Before we get into the details, I just want to show you the sketch working. I've already uploaded it to my ESP32, and I'm going to start up the serial monitor and wait a few seconds for the ESP32 to go out and fetch that text. And here it is. So I'm going to stop auto scroll. So down here you'll see a line, hello, this text is stored in a remote file. And this is the content that I've actually stored inside this little test_file.txt. If I have a look inside its contents, you'll see that it's hello, this text is stored in a remote file, the same thing that you see here in the serial monitor. This file is stored, as I said, on Amazon S3. Got a bucket here, and inside that bucket, so here's the name of the bucket. Inside that bucket I've got a directory, and inside this directory I've got a couple of text files. This is the file that my sketch just fetched, and this one here is another text file that I'll be showing you how it works in another lecture. It contains information that controls an LED, but we'll talk about that, as I said, in another lecture. Let's make a little change just to be absolutely sure that this sketch works. And I want to make a little change to the information inside the text file so that next time that this file is fetched, that change is also shown. So I'm going to open that with text edit or any text edit I will do. And I'll just say here, hello again, exclamation mark. All right, now just save that. I'm going to upload this file to replace the existing file on Amazon S3. Just drag and drop. Next, make that publicly readable. And next again, and upload. So one upload or one operation in progress. I'm not sure what the error is, but I can see here that the timestamp is correct. So the file has uploaded, and let's see. I'm going to go back to auto scroll, and we've got hello again. So the ESP32 was able to fetch the latest version of this text file. Another thing that I want to show you here, what happens in the serial monitor is the HTTP response to the GET request that my ESP32 is sending out to the web server. So here you can see a couple of lines that tell me what is happening, and those lines are generated by the sketch itself. So we're going to come back to all this in a minute, but I just want to show you the interesting bits. So here is requesting URL and then the URL. So just nothing fancy here, just a normal serial printouts. So here is requesting URL. And then below that, we've got the client.print function, to which we pass and actually construct on the fly the text string that represents the GET request. So we use the plus function to stick strings together. So text strings together. First, we've got the HTTP verb get, followed by a white space or a single space. Then we have the URL. The URL is this string here. And then we connect that, or we append that to a blank space followed by the version of the HTTP protocol that we're using plus a return. So that will then generate the GET request. In the header of our request, we also provide the host parameter. The host is the domain name for the web server. In this case, it's this thing here that I've got highlighted. It's a bucket on Amazon S3. And then we simply close the connection and we wait for a response. So all that is happening on the ESP32 end. And then a few milliseconds later, the web server responds with this. So this is the HTTP response to our GET request. It contains two parts. The first part is the header, which I've got highlighted here. And the second part is the payload, which I've got highlighted here. And they are separated by a blank line. Now, of course, the server sometimes may be busy doing other things. It may not be working at all, maybe down. And we need to take that into account. And that's what happens here. So between lines 100 and say 106, we've got a bit of code that counts the amount of time that it takes for the web server to respond. And if it takes over 5,000 milliseconds or 5 seconds, then we stop the client object and return. So we stop waiting at this point. But if the time is not out, if it doesn't time out and the server responds within the 5 seconds, then we move on to this part of the code where for as long as the client has got still available text in its buffers, so for as long as the client is still sending us text, we take the text one line at a time and then we print it out to the serial monitor. So this piece of code here is what emits all of this, because all of this is a response to our GET request from the server. That is about it. That's how this sketch works. Now, the bits that I omitted earlier are bits that you already know about. So here's where we include the Wi-Fi header so we can access the functions that come with Wi-Fi. This is where we note down, we write the credentials for the Wi-Fi network. These two variables are new. So this is the host for the web server. In my case, it's my S3 bucket plus the URL for the resource that we want to access. And then these two are combined later on in the loop to create the GET request. And inside the setup, we do the usual that are required in order to connect to the local Wi-Fi network. So all this is exactly the same as what you've learned about in the previous lecture. As you can see, it's fairly easy to create an HTTP client on your ESP32. The main problem here is that this client is not secured. As you can see here, we'll create a client object from the Wi-Fi client class. We specify the HTTP port to be 80, and then we use this information with our client.connect function to create a connection to the remote web server. But this connection is not encrypted. The GET request goes out in the clear. And although that is not a problem for a little example like this, there's no important information that is circulating around the internet. But imagine other applications where security and encryption are important, like you could be working on a security system, for example, or you may be transmitting sensor data from your lab and things of that sort. Then you will want to be using TLS encryption and doing all your communication via the HTTPS protocol instead of clear HTTP. So I'm going to show you how to do exactly that in the next lecture, where we'll use the same sketch as a framework and build on it the infrastructure needed for secure encrypted communications. So let's check this out next.